Statement A. I believe Grid Search CV's main job is to hunt for the best settings, hyperparameters, for a machine learning model. For support vector machines, SVMs, two important settings are C and gamma. Therefore, this statement is absolutely true. Statement B. I want to clarify that Grid Search CV doesn't automatically adjust your data. It focuses on finding the best hyperparameters. Data scaling is a separate step, usually done before using Grid Search CV. So, this is false. Statement C. Grid Search CV is clever. It uses a technique called cross-validation to test different hyperparameter combinations and prevent overfitting. This is indeed true. Statement D. I should point out that Grid Search CV is a very versatile tool. It isn't just for classification problems, it works with regression problems too. So this statement is false. This statement simply introduces the topic. We're examining how Grid Search CV, a tool for finding the best settings, hyperparameters, for a machine learning model, works when used with support vector machines, SVMs, a specific type of classifier. It sets the stage for the upcoming true-false questions. I agree, that's absolutely correct. Grid Search CV is designed to do exactly that. Find the best combination of settings, like C and gamma, which control the behavior of an SVM, to make the model as accurate as possible. This confirms that statement A is true. Nope, that's false. Grid Search CV focuses on finding the best settings, not on preparing the data. You still need to scale your data, like making sure all features have similar ranges of values, before using it with an SVM. Grid Search CV won't do this for you. This indicates that statement B is false. Absolutely, this is true. Cross-validation is a clever way to estimate how well a model will perform on new, unseen data. Grid Search CV cleverly uses it to test many different setting combinations and pick the best one. This confirms that statement C is true. Incorrect. That's false. Grid Search CV is a general-purpose tool. It is not limited to classification. It can also be used for regression problems, predicting continuous values, not just categories. This shows that statement D is false. I see Grid Search CV as a powerful tool in Sklearn. It systematically explores different settings, hyperparameters, for a machine learning model to find the best combination. Think of it as a highly organized and efficient way to tune your model for optimal performance. It's like trying different wrenches to find the perfect fit for a bolt, but much smarter. Support vector machines, SVMs, are a type of powerful machine learning algorithm. They're especially good at classifying data. Imagine drawing lines or curves to separate different groups of data points. SVMs do this in a clever way that maximizes the margin between groups. The C and gamma parameters control how these lines, curves are shaped. This is what Grid Search CV helps us optimize. This statement is absolutely true. That's precisely what Grid Search CV does. It efficiently searches for the best values of C and gamma for your SVM to find the best model settings. C controls the penalty for misclassifications, and gamma influences how wide the margin between data groups should be. Nope, this is false. Grid Search CV focuses solely on finding optimal model parameters, not on pre-processing your data. You'll still need to scale your features independently to get good SVM performance. It's a crucial pre-processing step. This is true. Grid Search CV uses cross-validation to avoid overfitting. It tests different combinations of C and gamma on multiple subsets of your data. This gives a more reliable estimate of how well your model will generalize to new data. It's like testing different recipes on various ingredients. We use Grid Search CV here to improve our churn prediction model. Customer churn prediction involves identifying customers likely to stop using a service. Grid Search CV helps tune the SVM model to improve its accuracy in this prediction task. Let's find the best parameters to make accurate predictions. This is the main question for the quiz. I am analyzing each option to verify if it is correct based on how Grid Search CV works within an SVM framework for a churn prediction problem. False. Grid Search CV is a general tool. It isn't limited to classification only. It also works very well with regression models, where you predict a continuous value instead of a category. I see this as the main topic. We're focusing on how Grid Search CV, a tool for finding the best settings, hyperparameters, for a support vector machine, SVM, works in classifying data. This is the core question. I'll examine each statement carefully to figure out whether it's true or false about Grid Search CV. This is the star of the show. Grid Search CV is a scikit-learn function that automatically searches for the optimal hyperparameters. Think of it as a hyperparameter tuner. It does so using a technique called cross-validation. This is what Grid Search CV does. Hyperparameters are settings that control how our model learns, like dials on a machine. Grid Search CV systematically tries different dial combinations and picks the ones that yield the best results. Support vector machine, SVM, is a specific type of machine learning model, and here it is used for classification, sorting data into categories. Grid Search CV is used to find the best settings for this SVM model. Cross-validation is a crucial technique that Grid Search CV uses. Instead of training the model on the entire dataset and testing it once, I use cross-validation. It means I split the data into multiple parts and train on some parts and test on the others repeatedly. This gives a more reliable estimate of how well the model will generalize to unseen data. It helps avoid overfitting. I'm tackling a problem about GRIDSEARCHCV, a tool in SKLEARN, used to find the best settings, hyperparameters, for a support vector machine, SVM, model that predicts customer churn. It's all about understanding how GRIDSEARCHCV works. We'll examine some claims about using GRIDSEARCHCV within SVM for classification, and we'll determine which ones are correct. This statement is true. GRIDSEARCHCV is specifically designed to do that. In SVM, C and GAMMA are key settings that control the model's behavior, and GRIDSEARCHCV helps us find the best values for those. This one is false. GRIDSEARCHCV focuses only on finding the best hyperparameters. It doesn't automatically scale or transform your data. That's a separate pre-processing step that you must do yourself, usually before feeding the data into GRIDSEARCHCV. This is true. GRIDSEARCHCV cleverly uses a technique called cross-validation. It tries out many different combinations of hyperparameters and assesses their performance using cross-validation to get a reliable estimate of how well each combination generalizes to unseen data. This helps prevent overfitting. This is false. GRIDSEARCHCV is actually a very versatile tool. It's not limited to classification. I can use it with regression problems, too. I'm tackling a problem about Grid Search CV, a tool in scikit-learn that helps find the best settings, hyperparameters, for a support vector machine, SVM, model used for classifying whether customers will leave, churn, or stay. It's all about understanding how Grid Search CV works in this specific machine learning context. This question tests your understanding of how Grid Search CV functions with an SVM classifier within the scikit-learn library. I'll help you analyze the given statements to figure out which ones accurately describe Grid Search CV's capabilities and limitations. Let's dive in. This is absolutely true. Grid Search CV's main job is to systematically test different combinations of hyperparameters, like C and gamma, which control the SVM's behavior, and pick the best combination based on how well the model performs. This one is false. Grid Search CV focuses solely on finding the best hyperparameters. It doesn't automatically scale your data, and scaling is usually a crucial pre-processing step for SVMs to perform optimally. You've got to scale your data separately. That's a resounding yes. Grid Search CV cleverly uses cross-validation. This means it evaluates each hyperparameter set multiple times using different subsets of the data to get a more reliable estimate of how well it generalizes to unseen data, preventing overfitting. Nope, this statement is wrong. Grid Search CV is a versatile tool and isn't limited to just classification. It can be used with various types of models, including those used for regression tasks. This instruction tells you to choose all the statements that are correct from the previous options. Remember, only options A and C are true. Makes sense?